The character tokenization is very straightforward, and we may not need an extra library to do it. By using native Python list functions, we can split our text into character tokens. For word tokenization, it is much easier than subword tokenization because it simply splits the tokens based on the space between two words. There are many libraries that we can use. We can use native Python functions to split words, and then we can easily split the sentence into a number of tokens. Alternatively, you can use regular expressions as well. Using the /w means splitting the word based on word characters. One thing I want to mention is that for this method, because we have a very simple regular expression, you can see that the full stop is removed, while in the previous method, the full stop at the end of the sentence is kept. Another option is the NLTK library, which is quite famous. It comes with many great utilities, including a very nice word tokenizer that can handle punctuation as well. Lastly, there is spaCy, another famous NLP processing tool. The output is similar to NLTK's, but I recommend understanding more about it. Although there is a little learning curve, it is worth spending some time on it as it comes with many great features and customized functions. Besides splitting space, we can also build bigram, trigram, or ngram tokens for our process. We do not need to build them from scratch but leverage the NLTK function to help us build them. For subword tokenization, most of the recent language models will have their own tokenizer because they want to overcome the out-of-vocabulary problem. This is why they use some calculation to figure out which subwords they should keep. Different language models may have different subword tokenizers. For example, we have the BERT-based case model, Tokenizer 1, and we have the second one, which is the RoBERT-based model. They use different reprocessing steps and learning algorithms so that tokenizers are different too. Taking the example Bunny loves NLP, you can see that for the first one, it will tokenize Bunny loves NL and ##P, resulting in 4 subwords in total. On the other hand, the second tokenizer only produces 6 subwords. Sentence tokenization is a relatively straightforward process. It involves splitting text based on specific punctuation marks, such as full stops and question marks. Both NLTK and spaCy provide reliable sentence tokenization capabilities, and the results from both libraries are generally consistent. If you're interested in exploring further, I highly recommend dedicating some time to familiarize yourself with the spaCy library.